If you've ever used Blender's experimental feature called Adaptive Subdivision, you've probably had the same experience as me, where you get this message when rendering. Now, no one wants to see that, so I fixed it. I made a geometry nodes group to do a very similar thing, except it renders about 25% faster and uses way less VRAM. Now, obviously, doing it in geometry nodes does have its drawbacks. It's often slower in the viewport and can be taxing on your CPU and RAM depending on how many subdivision levels you're using. But for me, those trade-offs are well worth not using literally all of my VRAM. It has some other benefits too, like being able to see what's being subdivided in your viewport, and you can actually apply this modifier, or use it in geometry nodes if you know what you're doing, to edit the geometry, which can be used for all kinds of cool effects. It can also be used in Eevee, which isn't a thing with the base adaptive subdivision. Now, if you prefer to read about it, you can go to my Gumroad or Blender Market and read about its capabilities there, and maybe pick it up if it looks useful to you. For those of you who prefer to watch a video about how to use it, let's get into it. So the first thing I want to showcase is the thing that's probably most similar to like the default base adaptive subdivision that's built into Blender, and that is the camera dynamic tessellation. So if I play this, you'll see as the camera gets closer, it subdivides the object just in the camera's view. And you can see these patterns appearing. That's because if I go into my modifier, I'm using a displacement map, and I'll get into all of these settings later on. But for now, I just want to showcase what the node group can do. The displacement that I'm using to modify where it gets subdivided helps the render to like avoid pop-ins and stuff. And since I'm doing this on the CPU, because geometry nodes obviously runs on the CPU, not the GPU, we can't have like those really tiny micro polygons that you'd get from a GPU dynamic tessellation. So these polygons are bigger, which will result in a loss of quality versus the normal adaptive tessellation. But in sacrificing that, you get something that, in my experience, performs better and is less prone to crashing. And it works in Eevee, which obviously the normal one doesn't. And you can see from this rendered view, it looks pretty decent. This is in Eevee Next. And I'll put a video of what it looks like rendered in cycles up on the screen. So you can see, you know, what's going on there. It looks pretty decent compared to the normal adaptive tessellation. So in the settings here, there's a cache button. You can see in my timeline, there's this purple line, and that's because I have this cached. So if I turn cache off, it's no longer going to be using that. You can see it's a lot laggier. You can see as I rotate the object, the subdivision stays just only in the camera view, which is going to reduce your polygons by a lot. If you had to subdivide this, like you can see here, I'm using 4 subdivision levels. So if I mute this and add a subdivision surface with 4 levels, we're looking at, on mine, there's 77,000 triangles. On, if you subdivide the whole object, we're looking at almost 800,000. So, you know, a huge decrease when you're just subdividing within the camera's viewpoint. And one cool thing about the cache, if I delete the bake and then I turn cache back on, you'll see if I'm playing this, it's laggy, but then the camera stops moving and it speeds up. Now that's a feature I really wanted to have. I wanted to make sure that if the camera's not moving and the object isn't moving, then it's not going to have to calculate anything. So if I just go ahead and reset it, I'll show you again. When the camera's moving, I'm getting 12 FPS, 10 FPS, and then when it stops, we're getting solid 25. And if I rotate the object, it's going to go down again. So it only calculates when something is moving in the scene, which is very useful for bake times. So set this frame range back, and I'll keep cache on, and then I'll bake it. And I can actually show you how long it takes to bake. On my machine, it takes, I don't know, 30 seconds to a minute for this animation. And you might notice this band of polygons that goes around the whole sphere. If I go into camera view, you can see what that is. That's on the grazing angle of the camera and the object. And that helps a lot with pop-ins. That is what kind of upkeeps the silhouette of the object. So if you don't have this, you can get some really bad pop-in on the edge of the object when you're going from far away to close up. And obviously there is pop-in. Let me turn the cache back on. There's pop-in in just, generally using it. This is only 4 subdivision levels. If you want it high quality, you can turn that up, obviously. But the pop-in isn't too bad. And in a case like this, where it's the only thing you're looking at, you're going to see it more. So let's get into some of these settings. First off, we just have the subdivision level. In this case, it is 4. And that's basically just the max subdivision level, obviously. So we're going from 0 levels to 1 to 2 to 3 to 4 here. And then we have the subdivision type, your normal Catmull-Clark or simple. It's defaulted to Catmull-Clark because that's what the subdivision modifier is defaulted to. And then we have cache. This just remembers basically what settings you've input after you've played the animation once. Or if you have the object selected, you can go down into this physics tab and hit bake. I would recommend doing that once you've got all your settings down to like what you want. For now, I'm going to turn it off because I want to show you what all the rest of the settings do, and I can't do that if it's baked. So use that like once you have all your settings set in stone. And next up, let's go into the first panel, distance mask settings. I think this one's pretty self-explanatory. The minimum distance is basically where the subdivision ends. So at 1 meter, it will be subdivided to whatever you have this at, in my case 4. So at 1 meter, it's going to be subdivided to 4 levels. And then the max distance is 40. So at 40 is where the subdivision will stop. And you can modify these based on, you know, what you got going on. And then we have the easing type, which is basically going to control how the subdivision levels are distributed. If I go into this collection, you can see we have all of our easing things here. So linear or none, as it's put in the modifier, is going to have an even distribution of your subdivision levels. You can see here all of the bands are about the same width. But then once you get into easing types, you can think about this as the steeper the curve, the more subdivision levels will be in that area. So here the curve is steep at the start, so there's more subdivision levels at the start. And then they ease out into being unsubdivided or not subdivided. Same thing with ease in. You can see here the steeper area is at the end, so the end has the majority of the subdivision levels, and then the start is more one level. And then we've got ease in out, which is, you know, just these two combined. So if this one is more levels at the start, this one's more levels at the end, this one will be more levels in the middle, basically. You can see there's a grouping in the middle, and then bigger band, bigger band. So let's get back to the other settings now. The easing exponent, you can see on this one I'm using ease out. And the easing exponent is basically how harsh that's going to be. So those are all the distance mask settings. Like I said, I think pretty self-explanatory except for the easing type. And then we've got grazing angle subdivision, which I was talking about a little bit earlier. So I've already explained, you know, what that does. We've got the subdivision levels here. You can see if I turn this subdivision level up higher than the one you have up here, it's not going to do anything. So it's maxed at whatever you have this one set at. And then the threshold is kind of how much it takes up. And then the smoothing is kind of similar, but you see if I set the smoothing to 0, the threshold is going to be a very harsh line. So it's kind of just cut off, like where does it end? And then the mask smoothing will smooth that out. So you got to use those kind of in tandem. So I'm going to set this to 1 and that's 5. That's what settings work for this one. And then now we're getting to the image settings. So I'm going to open both of these panels. First off, we have the fix UVs setting. If I go back here, let's just choose this one. And I give this this material, which is just a basic wave. You can see the UVs are really messed up around the seams. So if I go into the settings, let me collapse some of these panels, go into the UV image settings. If I click on fix UVs, it's fixed. And it looks great now. You can really see the difference. So if you're going to be using UVs on your object, then definitely use this setting. The UV map name is just the name of your UV map on the object. You can find that in the data panel. And then UV maps, you can see here, mine is called UV map. That's just the default for primitives in Blender. So, but if you're not using UVs, I would recommend turning this off because it does kind of take a hit on performance. You can see here, without it, we've got 12.7 milliseconds, and then with it, 17.2. So it does slow it down a considerable amount. And then getting onto the displacement settings. The displacement map settings, I would recommend using if you are doing displacement with this. Currently, it doesn't support vector displacement. I would like to implement that in the future. But if you're using a UV map, and a displacement map, I would put the displacement map in here. And then if I turn this to 0, you see we have a harsh cutoff on the subdivision level. But if I put this displacement fact a little bit up, we get it going in areas where the displacement map is changing a lot first. And that helps a lot with pop-in. It focuses more on the areas of greater change first before it, you know, subdivides anything else. And if I put this all the way to 1, it's gonna look really weird. I wouldn't recommend putting it that high. Just keep it kind of low. And then the image map is for the displacement map, or image mapping. If I go into, let me open up a shader editor tab, and then we've got the displacement, or we've got the node group for this shader, all my image textures, and then we've got the displacement map, and you can see here we have a mapping node, and there is a, location, rotation, and scale. I've got translation, rotation, and scale, the same thing. And so whatever you have in here, you should match in these settings. And if you're doing like a more complex, node setup, you've got some vector math. You can add, whatever you're doing. If you're doing that, you're gonna have to add them into the node group yourself. If you know how to do that, great. But if you don't, then just use the mapping node. It works fine for most cases. I think that's it for the image settings. It's not too complicated. And then camera mask settings, which is the last one. Let me get rid of this actually. In our camera mask settings, we've got just your settings for your camera: resolution X, resolution Y, focal length, sensor size. You can find the resolution in this tab right here, and the other stuff is in your camera's data tab. You can see the focal length is right here, and the sensor size is in this camera area. And you can set up drivers for that if you want it to just do it automatically when you're changing your camera. Unfortunately, Geometry Nodes currently doesn't have the ability to just like access those values. I would love it if they did, but I digress. The other settings are pretty simple. We've got your mask smoothing. So if I set this to 0, you can see it's really harsh. And I think, yeah, you'll actually see some of the unsubdivided polygons in the camera. So mine at 4 works fine. I could honestly probably turn that down even more. Yeah, I could put that at like 2 and it works fine, but 4 is better. You want this kind of smooth fall off of polygon density, or you'll have like harsh shadows and stuff with displacement. And then the last setting is only camera facing faces. So if I turn that off, you can see all of this stuff gets subdivided because it's technically in the camera's FOV, but you can't actually see it because it's blocked by other things and it's not facing the camera. So if I turn this on again, you can see all of that stuff goes away. It adds about 300,000 triangles by turning that off. So I would definitely recommend keeping it on for most cases. So that's the camera version. If I go into this area where I displayed the easing, this is the object version. It's the same exact thing, except in this case, I've got empties controlling where it goes. So this can be useful for some cases. Something that hits an object like this, you could have it just be subdivided around this area so you're not adding unneeded polygons. And that's the benefit of this node group, or one of them, is that since we're doing it on the CPU in geometry nodes, we have all of this in our viewport and we can apply it if we want. See here, I just applied it. Now I have all of this stuff to actually work with. You can't do that with the normal adaptive subdivision, but with this one you can. So I'm not going to go over any of the other settings. The only added one is the object setting, which is the one that the subdivision springs from. And you've still got like camera mask settings, which you can enable or disable. I have it disabled for these. And then on to the last thing. I've actually set up a couple of Geometry Nodes tools, which are a new addition in 4.2 or 3 or something. I don't really remember. But basically, I've set it up so that if you go in edit mode, and you have a face selected, you can go to face, and then we have these two dynamic tessellation options. We've got distance and Dijkstra. Distance is what I've been showing you so far. It's just in a like radius around. If I select that, you can see it's subdividing around where I had selected. I can change all of the normal settings. If I go in rendered mode, you can see we've got the same UVs fix as normal, and we've got all of your distance settings that we have in the other one. So that one's pretty self-explanatory. The Dijkstra one is maybe a little less obvious. Dijkstra is a pathfinding algorithm, and I'll show you what that means. So if I select this face and I do face dynamic tessellation distance, and I'll set this to simple, you can see we just have these rings, and that's what you'd expect from distance. You're just subdividing in a radius around what you have selected. So if I Control Z that, and then I go to face Dijkstra, and I'll set this to simple, now you can see it's kind of spreading from where we have selected. If you need to have your subdivision on like only connected faces, something like that, you can see it's spreading from the face that you started on. So this can be useful, like I said, if you're doing it on only connected faces. And like if I Control Z that, and you'll see I've got Suzanne here. Like if I want to subdivide around her eye, I can go face, dynamic tessellation distance. But if I do that, it's also going to subdivide the eye. So instead, I can do the Dijkstra version, and now it's just subdividing on unconnected faces without doing the eye. I can set this however high I want, and it's only the ones that are connected to the original selected face. So that can definitely be useful. And we've got all the normal settings. We've got the normal settings. In this one, the distance is a face value, so it's like however many faces away from it. This would be a distance of 0, 1, 2, and then the same UV map fix still applies here. Just make sure you input the name of your UV map, or it's going to get really messed up. And if you're expecting this to be faster than the built-in adaptive subdivision, you're going to be disappointed because it's not. Like I said before, it's running on the CPU and not the GPU, which is going to be inherently slower. This is just a more stable version, and you can actually see it in your viewport. You can see what is being subdivided. And it uses less VRAM, which is kind of my main draw because I've been using adaptive subdivision for projects recently, and it has just been eating my VRAM. I only have 8 gigabytes, and it really sucks. So that's kind of the main reason I made this. And then I've had some people tell me that they would like it as a product. So this will be on my Gumroad and Blender Market. If you have any feedback or bugs, let me know. You can comment here or message me on Blender Market. Those are probably the 2 easiest ways to get to me. I hope you guys enjoy this product, and yeah, have a great day.